All right, cool.
All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your question, and we will try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature here, so we do encourage you to chat us your comments, questions, suggestions, whatever you want to share with us, and we'll keep an eye on that chat, and hopefully maybe we can get you more engaged and we can chat you back. And at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is enabling SREs to streamline service delivery with advanced monitoring. Our speakers today are Bobby Hallahan, who is the Senior Specialist Solutions Architect at AWS, Richard Whitehead, who is the Chief Evangelist at Moogsoft, and Waldo Grunenwald, who is the Tech Evangelist over at Datadog. Gentlemen, thank you all so much for joining me today. I really do appreciate it. I know we're going to have a great presentation. Bobby, you're kicking things off, so I'm going to take myself off camera, put myself on mute, and just turn it over to you, let you get right to it.
Awesome, thank you. So yeah, welcome to today's webinar, everyone. And let's go ahead and get started. So we'll kick off with introductions of who we are. I'll start with myself. My name is Bobby Hallahan. I'm one of the Senior Specialist Solution Architects, or SAs, here at AWS, focusing mostly on observability, being that CloudWatch, X-Ray, and as well as a few of our open source offerings. Before working in this role, I also worked as a technical account manager, or TAM for short, supporting our enterprise customers in the public sector with their mission-critical workloads. So part of that is the well-architected principles at AWS of availability, or the performance, efficiency, and availability and reliability are pretty important or hit home for me. But with that, I'll pass off to Richard and let him introduce himself.
Hi there, Richard Whitehead, Chief Evangelist with Moogsoft. That basically means I'm a technical person who loves talking about the technology, and lucky enough to get to do it professionally. Been working with enterprise network systems, application management for a couple of decades now, and just it never gets old. It's fun.
Hi, folks. I'm Waldo. I'm a technical evangelist for Datadog. I used to be a productive member of society. I'm a recovering systems and operations engineer, and really bad at writing bios. But I think that's enough for today. Bobby, why don't you
Awesome.
keep us going here?
Thank you, everyone. Yeah, we'll do. All right, so let's jump into our agenda for today. So what we'll kick off with is a quick introduction on observability, what we mean by observability, and a few of those benefits, specifically using how observability can benefit us in accelerating delivery and being able to rapidly deploy new services, as well as providing reliability for our business. Then we'll pass it off to Waldo, who's going to give us a talk on DevOps versus SRE. And then from there, we'll conclude with Richard, who's going to give us a deeper dive on AI and observability. All right, so with that said, let's jump in. Okay, so for an introduction to observability, just like I said in the intro or the agenda, so I won't spend too much more time on this slide, but let's think about like why is having an observable system, so a system that has a property of observability, why is that important to our business? And what I'll start with here is being able to accelerate innovation and delivery. And by that, what I mean is when you have a system that is observable, you're able to know, predict what will happen when we are able to make changes. Or in some cases, even if we have a system that is reliable, so we have higher availability. We have maybe a little bit more leeway to experiment or iterate. Waldo is going to hit on this topic a little bit more during his presentation, during his part of this webinar. But that's one of the benefits of observability that may not be abundantly obvious or self-evident when you think of observability. One of those second benefits is also improving operational and financial efficiency. So what we mean by that is operational efficiency. If you have the right tooling in place, if you're looking at the right data points, when some sort of operational event happens, we're spending less time trying to identify what the cause of our problem is, or even less time even looking at like if we have the right practices in place, you're able to get the right people on the call that actually understand what the source of the problem is, and then the right mechanisms to then go about either doing some sort of rollback or doing some sort of remediation action. The net result of that is less time spent attempting to bring systems back to a healthy state, and more time spent being able to innovate and do cool stuff. And then, of course, financial efficiency. And by that, we mean of the resources that we have provisioned. So if we think of like a compute nodes or EC2 or maybe some sort of like block type storage, what we're thinking of is of the resources that we have, how well are we using them? Are there more efficient ways to consume those resources to run our workload? And then lastly, I'll look at lower business risk. So when we think of observability, we're thinking of a system that has observability is inherently going to lower our business risk by driving higher reliability, as well as better availability. This is probably the benefit that people, at least when I think of observability, this is the first thing that comes to mind. We want to think of having an application or workload that's highly available and reliable. But of course, I do want to hit on those first 2 points, because sometimes I feel that the lower business risk does overshadow these first two sometimes. So with that said, let's do a very quick overview of what we mean by observability and like what this, one of the key actions that you would interact with a system that has properties of observability, meaning the first really being detect. So something happens, some metric breaches some threshold. Maybe we have, maybe it's a customer-driven detection where customers are calling in saying something's not working, or it could be a proactive detection. In those cases, alarms go off, people are getting paged. Maybe there's a bridge call that gets established. Moving on to the second phase of investigate, where we try to identify what is causing this error, what that root cause is, and then lastly, remediate. Where good observability helps is specifically in the detect phase and the investigation phase. Now, from a detect standpoint, you're not going to get everything all the time, and it's an iterative process. So when we first set up a workload, we don't necessarily know every single thing we would want to alarm on, and that's okay. As long as we have that iterative process, we get better every time we do it. That's I think one of the key points to being able to do this well. All right, moving on. So now let's take a look at what I'll call these like 3 pillars of observability in terms of like data types. Of course, we have metrics, logs, and traces. All of these are helpful in their own ways, and I'll try to quickly explain them or summarize them. So obviously, a metric is a time series data point. Thinking of examples like CPU utilization over time, or maybe network I/O or disk IOPS. They could even be a business metric, so maybe like orders per second. These are things that are good for trending, plotting, and graphing. And they can also be good for okay, it looks like my screen may be frozen. So I'll just go ahead and go with audio for now. Yep. So metrics may also be good for when we have an alert. They're good as an alerting mechanism. So when something breaches a threshold, we can alert and then respond to it in kind. Now, next, when we look at logs, for example, logs are really good and rich sources of data. And in most cases, when we're doing some sort of log dive, it gives us the ability to understand what that potential root cause is. And lastly, we have trace data, which with traces are especially helpful in a distributed type application where we can take a look at the lifecycle of requests. So a request comes in, what components of our application did it hit? Where specifically did were any bottlenecks? Where specifically did the error originate from in our application? Very much useful in microservice type environments, but when we start combining metrics, logs, and traces together and are able to correlate all three of these, this is effectively these pillars of observability. And by building on top of the logs and metrics and traces, and then that's how, by using certain different types of tooling to get those insights, that's where we can start providing very powerful outcomes. All right, I will advance to the next slide. So quickly, I'll cover a little bit of what we have for Amazon CloudWatch and how this works if we're operating on AWS. So if you are operating on AWS, odds are you're probably using CloudWatch in some form or another. And I'll quickly summarize essentially how it works. So we've all probably have seen metrics such as like a vended metric or a vended log, examples being like the AWS EC2 namespace or the AWS logs namespace or the application ALB namespace if we ever run ALBs or NLBs. Vended logs being something like a VPC flow log. So these are where our services and our services are emitting metrics and logs to respectively CloudWatch metric and CloudWatch logs. Of course, you can use the CloudWatch agent and collect additional logs, additional metrics if you'd like to, but for now we're focusing mostly, let's think of like these vended metrics and vended logs. From there, we have some built-in tooling that we can use to do some analysis, alarming, and dashboarding capabilities. But what I'd like to highlight today is how can we take the data that is generated from AWS, and then how can we send that to our observability partners, such as Moogsoft and Datadog? Like how do we get this data so they can enrich it, correlate it, and add additional insights for us? And it's done a couple ways. One being the get metric data APIs. So we can pull the get metric data API, retrieve sets of metrics, and that's a relatively simple way to do that. There's also get metric statistics, which is similar to get metric data. I don't want to go too much in the nuances here, but I would say get metric data is probably the preferred way to do it. And then, of course, you can also leverage a metric stream where instead of polling an API, we can send the metrics to a Amazon Kinesis Data Firehose delivery stream, which has a plethora of delivery options, one of which actually including Datadog. From there, we can even go to, if we think of logs, like how do we get logs out? It's similar where we can leverage subscription filters. So we can look at for a specific log pattern. So maybe we're only looking for errors and we want to send those out. Or maybe I want to just send everything. So we can do fairly advanced pattern matching and then select different targets for those logs. So in this case, we are able to get out everything from CloudWatch and actually move it to or ship it over to our observability partners. But with that, hopefully I've given a quick introduction to observability and you found this helpful. What I'll do now is I will hand it off to Waldo, who is going to give us a intro on DevOps and SRE.
Yep, we're just waiting for my share to begin. It's fantastic. There we go. Okay. Hi, I'm Waldo. And again, I'm a tech evangelist for Datadog. This talk really isn't about Datadog, but we are a premier observability platform covering everything that you would want to have information on, from your front end to your back end, and we really democratize that information so that everybody in your company, whether it's your developers, your operations people, even the people in finance and legal, can have access to the same information, and also provide you with different types of information. Where in other tools you would have to change context and rebuild your query to get where you were, that information you would want is just a click away. So today we're talking about enabling SREs to streamline service development delivery with advanced monitoring. So I really want to focus on the SRE portion and kind of where that comes from. So the first thing I'm going to clarify is the difference between DevOps and SRE. DevOps is a professional and cultural movement that focuses on openness, sharing, and mutual respect. It seeks to improve the quality of life for its adherents, for your company, and for your customers. DevOps also addresses a situation where a lot of effort is spent on the development of features, but the operation of those features, making them actually available to your users, has gotten very little investment from businesses historically. See, availability is the one feature that any application needs, and that's driven by its reliability. But by the nature of most organizations, the people who write the features don't figure in reliability because the impact of the reliability isn't felt by them. So there's an acronym with a couple of variants that's helpful to describe some of the core tenets of DevOps. And the main acronym is CAMS. And this stands for Culture, Automation, Metrics, and Sharing. Now, sometimes you'll see CLAMS or COMS with the addition of L for learning. Culture asks us to be conscious of the culture that we're creating and participating in at work. Automation's focus is to reduce toil and make steps repeatable, less risky, and also freeing people up to do more interesting and rewarding work. We care about measurement and metrics so that we can see the impact of our changes and how successful they are. Sharing encourages us to be radically open, not just about our successes, but also our failures. And learning requires a degree of self-awareness, as well as being receptive to feedback. This is admitting when something doesn't work and changing it. Now, despite the dev and ops in the names, it isn't just about those two roles. DevOps is literally about the entire business, encouraging everyone to be aware of their role in business and that their work is aligned with the business's goals. So ultimately, there's no need to awkwardly add things to the word DevOps. Adding QA or security or net is unnecessary. They're really already included. Now, I say all of that because it's nearly impossible to describe SRE for site reliability engineering without an understanding of DevOps. SRE is a set of practices, and it can also be a job description. It could be said that DevOps is an idea, while SRE is an implementation. When the SRE book was published in 2016, many of us were a bit surprised to see that it looked a lot like Google-branded DevOps. Ultimately, SRE is the idea of how Google, in isolation, was addressing the problems that the DevOps community was also working on in public. The skills to look for a good SRE is outside of the scope of today. But in short, the people best suited for this are developers with an operations mindset, ops folks with some software skills, and also strong mentorship abilities overall. A problem that comes up in software engineering teams the world over is attempting to balance innovation with availability. Or perhaps another way to say that, if they don't discuss how to balance those things, it doesn't get balanced. Fortunately, also from the SRE book, we find a framework that helps us to balance innovation with availability, and that is service level objectives, or SLOs. Now, this may surprise you, but technical people love acronyms. And in this case, we've got three that are very similar, so it's easy to get them mixed up. So again, we're going to start with some nice, tidy definitions just to clear things up. We'll start with SLIs. A service level indicator is a quantitative measurement that expresses an aspect of a service. The key word here is quantitative. You have to be able to measure it with a reasonable degree of accuracy. It can't just be a gut feeling. It's fast enough. SLIs are the basis of SLOs. So let's look at that next. A service level objective is a target value for a service, as measured by an SLI over a specified time window. The idea here is to pick a reasonable value that should be maintained or strive for a given SLI. The core idea here is that an SLO is a target or it's a goal. it's something to aim for and is ultimately a way of measuring the success or failure of a service over time. Now, this might bring to mind SLAs, which many more people are familiar with, but oftentimes SLAs are already in place before SLOs are even considered. So what's an SLA? Excuse me. A service level agreement is a contract that defines the results and consequences of meeting or missing one or more promises. Agreement, promise, contract, these are all words that can be used to describe SLAs. And to be honest, they're more the purview of lawyers than engineers. These are things that come up in terms of service agreements, contractual agreements between your company and other entities. Now, the important thing here is that it's a statement that codifies what happens when a promised target is missed. In principle, that result could be anything, but commonly takes the form of a business decision or some kind of financial repercussion. When choosing an SLI, it's important to choose a metric that represents the user experience. You should look at things like how your user interacts with your product. What is a typical workflow? What services within your environment do they use? Do they interact with? And ultimately, what does the user want? What do they expect? What are they trying to do? Now, if your company has KPIs for a given service, that might be a good place to start looking for an appropriate SLI. But not all metrics make for good SLIs. Now, the reason that things like CPU utilization and number of lines per code commit and what your quorum looks like, these don't make good SLIs because they don't directly relate to the quality of the end user's experience. Your users just don't care about how hot your CPUs are running. SLOs are an SLI combined with a target percentage and a time window. Note that both of these examples are valid SLOs, but they measure different things. The first targets successful requests, while the other one wants them completed within 500 milliseconds, but doesn't care whether or not they're successful. This illustrates why you should be very mindful about what definitions for success that you choose. These two have very different potential outcomes. Now, it's exciting to think about a consequence-free world where you can move fast and break things. But personally, that's just not a world that I've ever lived in. So error budgets. These are the inverse of the SLO. So if you're looking for a 99% uptime for a given service over a week, that means over that week, you have 1% of that time to be unavailable. This is the amount of unavailability that you have to work with within that given time period. So once you have your SLO and are monitoring the SLI for the given time window, you should have widgets that easily demonstrate at a glance how much error budget that you have available to you. So when using the budget, if you don't have any budget or are in the negative, you should concentrate on building it up. And you would do this by freezing new feature development, improving your observability story, but more importantly, prioritizing dealing with your technical debt, dealing with the reasons why your service is unavailable. And if your SLO is currently being met, you have room to move, you have room to try things, and you actually want to spend that budget without exceeding it. Try out some new features, cut a new version of something you've been wanting to try, or experiment. This is a great time to do chaos engineering and resiliency testing. So a common question that comes up is, when should we look at our SLO status? To me, the most valuable times to look at it are when you're about to decide on the next task. This could be when you're doing your sprint planning, or when you've completed a task and you're ready to begin a new one. Additionally, that error budget can be spent when you receive alert. But maybe you just want to get this final thought out. You want to finish working on the task at hand before changing context to address that. If you have error budget left over, you can use it for that to finish what you're working on before addressing the alert. So in closing, SLOs are a great tool for deciding the kind of work that engineers should focus on. I'd like to say that they're also simple to implement, but the reality is that the setting up of SLOs is simple, but the management of expectations is more involved. And it's the human side of things that are going to take some effort. So with that, I'm going to hand off to Richard, who's going to bring us into the home stretch. As soon as I stop sharing. There we go. Richard, it should be in your hands shortly.
Okay, thanks very much, Waldo.
While we're waiting for it to load up, just a quick reminder, if you have a question for any of our speakers, please go ahead and use that question and answer tab and submit the questions, and we should have some time at the end to go through those questions. Richard, do you see the slides? Yeah, they're moving now. Okay, great.
Okay, I think it's caught up. All right. So, yep, thanks very much indeed, Waldo, for setting up that definition of SRE and DevOps. I'm going to probably continue on the DevOps theme a little bit there. And if you've looked at the abstract for this session, between Bobby and Waldo, we've probably covered most of the key bullet points, but there's one last one that I wanted to drill down on, which is the improving operational efficiency through automation and AI-based observability. And in particular, there's one kind of one buzzword in there, AI, that I wanted to touch on a little bit and try and demystify, because that's kind of these days that's a bit of a sort of a throwaway word. But I want to talk explicitly about what that is, what's available today, and how that can explicitly improve the lives of SREs and so forth. So should be able to move it. Okay, so improving service delivery with automation and observability. What does that mean? Well, the first bullet is obviously speeding delivery through automation. I think anybody who's been involved in sort of the DevOps experience and carries the title SRE is probably as obsessed as I am with automation. It's fantastic. What that means is basically using APIs wherever they exist, using them aggressively to integrate products and tools into the tool chain to get maximum sort of automation. The goal being, from our standpoint, monitoring as code. It's just something that happens and requires very little manual sort of intervention and touch. And that extends to sort of adding information in. So it's important to dynamically add context. And traditionally, I think we're very comfortable with doing that from external sources. Historically, we've leveraged CMDBs, configuration management databases, to get sort of status and change information. But also with the advent of sort of more sophisticated machine learning techniques, we can actually start to extract data from the data itself. And you're talking about sort of AI and ML technologies, when focused on a very specific task, they can yield tremendous benefits. Hopefully I'll be able to explain to you why they can be less brittle than hard-coded correlation rules and far more scalable, and more importantly, require less maintenance effort and substantially reduce the total cost of ownership of a platform. Okay, so before I go into a little bit more detail, let's just sort of go back and talk about a key DevOps concept, the 3 ways. The first way, represented here by the arrow from dev to ops, is system thinking, flow. This is the getting code from concept and been written to actually in a customer's hands and operational. The second way is amplifying feedback. That's the ops to dev loop. And then the third way is the kind of culture of continual experimentation, which is represented by the little loops. Now, when you look at this sort of diagram, you would intuitively think, well, monitoring, observability, that's the second way, right? That's the feedback loop. And it's absolutely true. But we also think, today, 2021, people should be looking at integrating monitoring into the other ways as well. Monitoring should be built into the deployment cycle. So if you have tests and configuration and things, that should be built into the deployment cycle. You should, say, monitoring as code. Anything that impacts or configures or adjusts the monitoring capabilities, thresholds, and so forth, that should be part of your code, and it should be deployed as part of the CI/CD pipeline. And also, we think as part of the development pipeline too. I think if you can't fail fast if you don't know you failed. So monitoring should be a key component of the development process, maybe in a not full operational capability, but some basic sort of validation should be in there. So let's look at something, an example that's a little bit more explicit. Here we have some sort of an example of your monitoring sort of flow chain. On the left-hand side, you have your data sources. This would be sort of things like CloudWatch and metric streams that Bobby was talking about. You'd want to do some kind of aggregation. Very few organizations have a single source of observability information. It usually comes from multiple sources or multiple products, and you're going to want to aggregate that. And it could be another product that's doing the aggregation. For example, the example I use here is Datadog. Does a great job of aggregating data from multiple sources. The important thing from the representation in this diagram is not how you aggregate the data, it's what you do with it when you get it. And the idea is to be able to take that information. If you're dealing with time series or metrics, you're going to apply some kind of threshold. You want to do some kind of anomaly detection on that. If you're getting log messages or alerts, you want to understand the significance of that. Identify which ones are related. So there's a correlation component we're going to be talking about here. And then there's what do you do with that information when you've got it? So you're going to want to sort of drive notifications, maybe some kind of runbook automation. And as represented in this diagram here, you'll see Datadog on the right-hand side. You could even maybe use that information to open an incident in Datadog. That way you can experience this entire life cycle without actually leaving one application. And that's very important. The key component here, though, is I think I've used the words can or quite a bit. The key component here is that the composability. Products and services that you employ in this chain should match your workflow. It should match your tool chain, not the other way around. So good APIs and good integration is the key here. And actually have an example here. So this is an example of an incident that was generated from metrics and alerts that were derived from Datadog. They've been grouped together, and exactly how they were grouped together I'll touch on in a second. Talk about some of the techniques that are available to you to do that. And this is an example of the sort of obverse of that, which is having created an incident that is then pushed back into Datadog, so you can see exactly what's going on. Okay, so I sort of teased you a little bit talking about getting data out of or getting context and information out of your data. There are a couple of ways of doing that. The most obvious one is metadata that accompanies raw data. And unlike shirts, where labels are really annoying, labels and tags are incredibly useful in observability and monitoring. Here's an example. This is a Prometheus example. This is the Prometheus text exposition format. And you can see here that there's a label, method, and code that accompanies the raw time series data. and that provides additional context or sort of a dimension. This is something that's very prevalent, and you'll see that in multiple applications. Tags are incredibly useful in AWS. There's a very sophisticated tagging mechanism built in there that you can use. You can use tags which can be key value pairs. Datadog also supports tags. Tags are incredibly useful. There's no bad time to add additional information in the form of a tag to a message. It makes information much easier to digest as a human, but it also allows you to drive sort of computational sort of capabilities further downstream. And that's something I'm going to talk about in a second. Here's an example of a very sparse message. This is a stats.d message. Here you can see the context, or the metadata here is, we have a value, in this case 23, but if you look at the namespace, it says CPU percentage. That percentage is important metadata. That tells you that 23 is actually a percent. And the G indicates that it's a gauge, not a counter. So we know it's something that's going to go up and down. So very useful metadata there. It looks very basic, but still there's useful information in there that can be derived. Okay. Another way of adding sort of additional metadata and context is through enrichment. And there's a couple of mechanisms for doing that. Probably the one that most people are familiar with is sort of an external data source. So in this particular instance, a message comes through with a source of foo. We can look at an external data catalog. And this is the pattern that's most closely matches the CMDB type pattern, where there's an external sort of data dictionary that contains additional information. And we now know that the source foo is part of the service bar, so that information can be added to the message as an additional tag, and away it goes. Now, the thing that we feel very strongly about is this is something that shouldn't be manually maintained. This is something that should be dynamically generated as part of your toolchain. So when you provision things and when you do builds and when you deploy, this data catalog should be dynamically updated via API. Humans should not be editing this. Another example of getting data is through feature extraction. This is from the data itself. And we go back to our sort of humble stats.d message here. You actually see that it potentially can contain more information than we initially thought. When we look at that namespace, we can see that there's potentially additional information. We can see that the first section, handily separated by periods, is the service. Then there's the host name, the source of the data, and the final component, which was CPU, allows us to determine the class of the message. So, it's possible with sort of machine learning and linguistic techniques to use sort of matches to look at something like CPU and determine that it's can auto-classify it as compute. And finally, we talked about sort of grouping messages together, and that can be done through clustering. So that provides additional context. So let's look at this particular instance. So we've either inherited or added a service tag to determine what part of our application this message comes from, and it's going to be checkout. Now, like I say, tagging and labeling something that is so most developers are well disciplined to do, but it's not always easy to get exactly the right phrase. So you can see here that the service is spelt slightly differently. It could be using camel case. It could be have spaces in or so forth. But the point is that we can correlate all of these together using natural language processing. And I know what you're thinking. You're thinking, looking at that thinking, well, surely I could just do that with a simple regex. You could. It wouldn't be that difficult to create a regex that looks for the words check and out with 0 or more spaces. But it would only work for the word checkout. If the word out didn't exist, it probably wouldn't match. And if there were other services as well, every time you created a new service, you would have to add an additional rule. So by using natural language processing, we can look at the similarity of these words and break it down to the fact that there's a stem word, in this case, check. We don't care about the other words necessarily. We don't care about capitalization. And we can just simply set a sort of a similarity, a Jacquard similarity of maybe 75%. And we can see that any combination of a phrase that contains the word check would probably match. And this creates sort of a correlation definition that is very, very robust. So minor typos are going to be tolerated. But also, if you create a brand new service, you don't have to touch the correlation rule at all. Machine learning takes care of that for you. Okay. So, in summary, what's this advanced monitoring doing for you? Why is it important to an SRE? Reduce downtime. Anything that can get you to the answer quicker is going to help reduce downtime. You're going to diagnose problems quicker. That's going to drive down your MTTR. Important. Reduced effort in generating rules and so forth. That breaks down toil. Nobody likes toil. That allows you to concentrate on the real job, which is improving sort of everyday work and improving efficiency and getting new features and functions out, and increases productivity. But the key point is that it's basically reducing manual effort. So that's kind of brings us to the end of our session here. If you're interested, there's an opportunity to trial both products. There are a couple of links there. I'll leave this up for a second or two for folks to sort of grab the links if they need it. Both Moogsoft and Datadog are available in the AWS marketplace. Moogsoft is also available in the Datadog marketplace. And so I'm just going to leave that up there for a second before we go to the Q&A session.
All right, great. Yes, we are at the question and answer session. Let's go ahead and leave that slide up so folks can get all the information they need from it. You can also look in the handouts section. There are some handy handouts there for you, including Moogsoft on AWS Marketplace, and so you can get all the information there you need in the handouts section. But let's go ahead and move on to the question and answer period. And there is still plenty of time, guys. If you have a question for any of the speakers, please go ahead and use that question and answer tab and get your question on in. We've gotten some really great ones in so far, so let's just dive right into the ones that we do have. First one is, let's see. Where to go? Okay, so how can I ensure that the different components of my application stack are monitored? Waldo, you want to take that one? We'll start with you.
Sure, I'll take this one.
Okay, great.
So I think it would be appropriate to say that Datadog, between the three of us, Datadog's the best place to get all of your components and all of the pieces of your infrastructure, your services, and your company to start collecting metrics, whether they're all your core data, whether they're metrics, logs, or traces, like we talked about before, but also your to do synthetics and RUM testing, your security monitoring, and things like that. We have, I forgot what the official number is. I want to say it's about 450 integrations, whether they're cloud services, whether they're stuff you run on-prem, whether web services that are open source like Nginx or Apache, or closed source ones like IIS, or language-based ones for the applications you run in-house. We provide observability tooling for just about everything you're running, because we're probably running it too. And you don't necessarily have to run in the cloud. We run entirely in the cloud, but you don't have to. And it brings everything in one place, whether it's on-prem or in any number of cloud providers. That's what we provide.
All right, great. We have a very interesting question here from Anshul, who asks, how can SLOs be made more realistic? Does the SLI need to be measured for a certain time period to determine achievable SLO?
Yeah, that's a really good question. So SLOs, when starting off on it, the gut reaction is to, like, the initial reaction of most people is to try to start too ambitious. And that's really not helpful. First of all, 100% availability is almost always going to be the wrong target, because that also means you have zero unavailability. So unless this is something that is absolutely business critical, cannot tolerate any failure, and I struggle to think of a context where that's actually true, 100% availability is the wrong number. We also tend to talk in terms of number of nines, where say 3 nines of availability is 99.9% of time. And that may be valid, but you probably want to start much lower than that. The key to figuring out what SLOs you should be targeting is what your users actually need and the unavailability they can tolerate. So, and customers doesn't necessarily mean somebody at home. It can be another team within your company if you're running like a service that others are dependent on. So it is a fine idea when starting. If you have no idea what your availability needs are, and you have all of your executives trying to target 4 nines, looking at your previous availability data is a fine place to start. So look at the last week or the last month and to see how big were the consequences of having less availability than you might expect. If your company caters to 9 to 5 workers in just a given time zone in one locality, there's no reason to be trying to target 4 nines across 24 hours. It's just not necessary, and it's needlessly expensive. So in general, I'd suggest people start even if you don't have any data, start much lower than you'd expect. Start with 90% availability. This is also going to change. Like if this is an old mature service that isn't getting feature development, you'll probably want to start with your availability higher, because you're not doing as much new feature development. It's just not needed, and you can focus your attention on reliability. If it's a brand new service, or especially if it's like in alpha or beta, or you're still trying to figure out what it's going to solve, much lower availability is fine. Like if you're still developing something, you need that experimentation time. Reliability probably just isn't as important. So I hope that answered satisfactorily, if not over-explained.
No, it's great. The more information, the better. Here is a great question from Upender, who I believe I said that correctly. Upender asks, most of the log data is either in CW or flow logs. How does Datadog work on this as an observability tool, and is it real-time in nature?
Okay, since it's a Datadog question, I'm not sure about what flow logs are, but Datadog is a launch partner, and we have a lot of our integrations are very deep. So we do use CloudWatch data as well as other stuff that's available to us. So it's basically real time. You may get it a second faster by going directly to it, but that's generally not something that's going to matter in most cases. You're probably going to find more value in it being available and in context with your other sources of data.
Okay.
Does that answer your question, Upender?
Upender, you can use the chat if that didn't answer your question. We could certainly revisit it. Let's see, Richard, I've got one for you here. We use Jira Service Management for ticketing. So does Moogsoft work with Jira Service Management?
Absolutely. That's actually an area where the capabilities are really useful, where you want to be able to cut a ticket based on an actual issue rather than individual indicators of a problem. So that's a common use of the product. Absolutely.
Great. All right. Balaji asks, what is the difference between monitoring as a service versus monitoring as code?
Since I use monitoring as code as in my slides, I'll get that. So monitoring as a service is, obviously being able to provide monitoring with little or no sort of additional input or effort, something that's completely hosted, or and I think you could argue that both Moogsoft and Datadog, monitoring as a service, both deliver using SaaS. So there's definitely the service component. The bit I was trying to get to, where we refer to monitoring as code, is that monitoring solutions require some kind of configuration. Even our adaptive anomaly detection for metrics, which looks at the data and determines the normal behavior automatically. Even that has configurable parameters, such as the standard deviation that you're going to consider acceptable. So these configurable parameters, we feel, should live as code. So put them in GitHub, put them in GitLab, and that's where the information is pulled from when you sort of set things up. So it's not a manual configuration process when you go into the product. It's something that the configuration is committed to a repository, and it is treated just like code.
All right, great. Here's another one for maybe Waldo, you can take this one. How can I ensure that the different components of my application stack are monitored?
I think I answered that already, but we have...
You did. Sorry. Oh, you know what?
Okay.
You're right. I apologize.
That's
we
okay.
can move on to another one. That's fine. I'm sorry.
I did see another one.
Oh, yeah.
Is Datadog just an agent installed on OS layer, or is it used?
That's the one I tried to answer.
Okay.
I tried to ask you that one. I just grabbed the wrong one. I apologize. Yes.
Sorry,
yes,
I clicked on the wrong thing.
It
was
that's all right. Yeah.
So Linzu Chu, apologies. It is both. So we do work. There are parts of our service that rely on an agent running inside your environment, but we also have, especially for our APM portions, we're a module that you include for applications that you write and run yourself. We are a module that you include or import into your application, so that you can get that tracing data and help you find where the slow is in the application, what things are getting hung up on. So it depends on the use case, but metrics and logs typically come from the agent, and APM comes from include or import statements.
Gotcha.
And we also have a lot of other stuff in the API as well. So.
Awesome. All right. Quick time check, guys. We are about 7 minutes to the top of the hour. So I think we have time for one or two more questions before we close things down. Here's a great one. How can I access the Moogsoft Datadog integration?
So my recommendation would be that if you are running Datadog, you would go into the Datadog marketplace, and you'll find an entry for Moogsoft in there. And that has a well-documented integration listed. So that would probably be the easiest and quickest way to get set up with that.
All right.
And I'm really hoping, Charlene, that you're going to get to Mike's question.
Mike. Okay. Let me get to that one now. I just found it here. We've heard a lot about, is this the one? We've heard a lot about the potential use of AI in security, but we've seen very little detail on how AI would be used. Why? Primarily because AI or ML requires model building, and building a detection model is difficult. What's likely is AI will be used to build a business as usual, all systems normal model. Do you agree there's a difficulty in applying AI to security? This could be a whole webinar in and of itself.
Yeah, it absolutely could. And I like this question because it's a difficult one. So the yes, it's difficult. It's difficult to apply an AI to anything. It's because it's such a broad topic. What you have to do is you have to identify the problem, like determine what your outcome is, and then choose the appropriate technique to deal with it. So the problem with security is you're obviously thinking about things like the way this question was written. I'm alluding to things like user behavior analysis, trying to identify what's normal and then identify something that's not normal. So what that would require model building. So for me, the strength of AI in this context is more to do with unsupervised machine learning. So in other words, a machine learning that requires no real understanding of what's going on, it just figures it out for itself. So we tend to talk about things like black swans. So familiar with that particular bird. Swans are predominantly white, but occasionally you get a black one, and nobody knows why. It's very unpredictable. And that's the kind of issue that we're looking for here. And I think even more so than sort of general IT infrastructure type issues, security, we're looking for the black swan. The threat actors in this particular instance are absolutely deliberately trying to do something that's never been done before, to avoid detection. So any kind of AI technique that can identify something that you weren't expecting is going to really help you there. And the example I used earlier in the session was clustering. So clustering techniques are extremely good in a security context, because what they'll do without any bias whatsoever, particularly the example I used was linguistic. It'll say, these three things seem to be related. What do you think? And a human would look at that and go, well, A and B, yep, they absolutely belong together. C, not so much. That's not right. Mm-hmm. So these kind of techniques like clustering are really good at highlighting things that a human might be interested in. Sure, you'll get some false positives, but that's a lot better than the alternative, which is missing the situation. And I think that's absolutely critical. So,
all right,
difficult question, long-winded answer. I'm sorry.
No, I was going to say you actually did a really great job getting to the answer in the time that we had left, because like I said before, I really think that that's a topic that could be a webinar in and of itself. So good job with that, Richard. Appreciate it. Actually, I do want to appreciate everybody who did submit questions. Unfortunately, that is all the time that we do have for the question and answer period. And I know we didn't get to all of the questions, but please know that all of the questions are going to be going over to Richard and Waldo and Bobby. So I am sure your question will get answered by the respective companies if we didn't get to it during the question and answer here. So thank you for everybody who did submit questions, and thank you to Richard and Waldo for tackling them. Really do appreciate it. Just a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can go look for it there. Just go to the webinar section, DevOps.com/webinars. Look in the on-demand section of the webinars, and it should be right there waiting for you. Okay, before we close things out, I did mention at the top of the hour we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that for you. The first winner today is Sean M. Congratulations, Sean. Our second winner today is James B. Congratulations, James. Our third winner today is Anthony F. Congratulations, Anthony. And our fourth and final winner today is Christian F. Congratulations, Christian. And we'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Bobby, Waldo, Richard, thank you all for all 3 of you for such a great presentation. Lots of information in this one, lots of takeaways for the audience. So thank you again. I do appreciate your time and your expertise.
Thank you.
You're very welcome.
Wonderful.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.